Solving absolute value inequalities. Some review vocabulary from previous lessons. An absolute value is the distance from zero. A disjunction is a compound statement that uses or, meaning that your inequality will point in different directions. A conjunction is a compound statement that uses and, meaning your inequality points in the same direction. Now let's review solving inequalities, and we'll cover multiple ways of writing our answers. Treat each inequality as an individual. On the left-hand side, I subtract 3 from both sides, and that gives me x is less than or equal to -1. Or, on the right-hand side, I divide by 3 on both sides, and that gives me x is greater than 3. This is one way of writing this. There are other ways that you need to be aware of. This can also be written with a fancy bracket. X, a vertical line, means such that x is less than or equal to -1, or x is greater than 3, and close. Before I go to the next notation, I want us to first graph this. If I say x is less than or equal to -1, that means I'm starting at -1, drawing a solid circle, and I'm following the arrow to the left. So it's going to be everything less than or equal to -1. I also have an or, x is greater than 3. Because there's no equal sign, I have an open circle, and I point it to the right. It's greater than 3, so it's everything greater than. So the next method of writing it is reading from left to right. Well, how far to the left do we go? It keeps going and going to negative infinity. So we would say we're going from negative infinity all the way up to -1. Union, and then we're going from 3, and it's going to keep going to infinity, so I write the infinity symbol. Now I need my brackets. Now I can't actually hold infinity, so I use a parenthesis. The -1 is included. See how it's a solid dot? I use a bracket. The 3 is an open circle. I use a parenthesis, and then again for infinity, I use the parenthesis. This is another way of writing your answer, and you need to be familiar with all 3 ways. Let's try that again real fast. I had -2x is less than 8, which means I'm going to divide by -2. What I do to one side, I do to the other. The negatives 2 cancel. That gives me an x. I divided by a negative, which means I have to flip my inequality. It's greater than -4, because I divided by the negative. On the right hand side, I add 3. What I do to one side, I do to the other. That's going to be x is less than or equal to 5. Now, when you have an and, there's a specific way of writing this. Write one x in the middle, and then write the arrows facing the same direction. And then look, here I have the pointy side facing the x, I have the pointy side facing the x. That was supposed to be a less than or equal to, so I put my equal to sign on it, and I throw the 5 on there. Over here I have the alligator is eating my x, so over here I have the alligator eating my x. That means I need the -4 right there. This is one way of writing it. If I'm going to graph this, the best way to graph it is off of these up here. You can graph off the bottom one, but it's more difficult. So if I'm graphing this, I have x is less than or equal to 5. I go to 5, solid circle, less than is pointing to the left. I have x is greater than -4. It's an open circle because it's simply greater than, and the arrow is pointing to the right, so I have greater than is pointing to the right. So we know that our answer is only between -4, not including, all the way to +5, including. other ways of writing the answer. And the part that's really important, where do we start on the left? We started at -4, and how far to the right did we go? We went to 5. There's no infinity because we didn't go forever. Now the 5 is a closed circle, so I put a bracket. The -4 is an open circle, so I put a parenthesis. It's important that you know this notation. In the last lesson, we said that the absolute value of x is equal to a. That gave us a positive or a negative. If you have absolute value of x is less than a, you're going to have an and it's going to be written with the x in the middle. If you have the absolute value of x is greater than a, you have an or. Now this is handy to remember, but if you don't remember, that's okay. When working out the problems, we'll figure it out. Remember the steps for solving an absolute value. First, isolate the absolute value. You basically pretend that the absolute value symbol is a variable and solve for that. Then remove the absolute value signs, creating a positive and negative inequality. Now for inequalities, it's important to remember, flip the inequality sign for the negative equation. This is very, very important. Then solve both inequalities. Let's try this one. First, I need to get the inequality by itself. What's happening to it is being divided by 3. The opposite of dividing by 3 is to multiply by 3. What I do to one side, I do to the other. The 3's cancel out. Now I've completed step 1. Step 2 says to remove the absolute value sign, creating a positive and a negative. So I'm going to create the positive one right here. Nothing changes. And I'll create the negative one off to the right. -3, and I have to flip that inequality. Now it's a greater than or equal to. Now I've completed step 2. Step 3 is to solve both inequalities. First, I need to subtract 7 from both sides. 2x is less than or equal to -4. Divide both sides by 2, and that gives me x is less than or equal to -2. On the right hand side, I'm going to subtract 7 from both sides, and that gives me 2x is greater than or equal to -10. Now I'm going to divide 2 from both sides. They cancel out. X is greater than or equal to -5. Now if I was to graph this, I have x is less than or equal to -2, closed circle, moving to the left. Over here I have x is greater than or equal to -5. At -5, again a closed circle, moving to the right. So I'm going to be between and including -5 all the way to -2, also including. This means my answer will be with x in the middle. They're both or equal to signs. It's pointing to the x and eating the -2, pointing to the x and eating the -2. Over here it's pointing to the -5 and eating the x, pointing to the -5 and eating the x. Here's one answer. The other way of writing it, I'm included on both of them, so I'm going to use my brackets for both of them, starting at -5 going to -2, -5, comma, -2. Here's another one that's very good to know. I need to isolate my absolute value first. It's being multiplied times a -1/2. In order to get rid of the -1/2, I multiply times the reciprocal, which means I'm going to multiply both sides by 2/1. I also need to get rid of the negative, so I multiply by a negative. Whatever I do to one side, I do to the other. I'm going to multiply the 3 times -2/1. On the left hand side, 2's cancels out, negatives cancel out, which gives me the absolute value p minus 2 is less than or equal to -6. Notice, because I multiplied times the negative, I flipped my sign so that it's less than or equal to the negative 6. Now, think about a number line really fast. If I'm less than negative 6, that means I'm at the negative 6 moving to the left. So no matter what, my answer is going to be in the negatives. Well, can an absolute value equal a negative? The answer is no, it can't. What that means is we're already finished. I isolated my absolute value, and I know that it's negative. Since it can never equal negative, my answer is no solution. Here is another special case that's very important to know. Let's go ahead and go follow the steps. I need to isolate my absolute value, so I do the opposites. The opposite of subtracting 1 is to add 1 to both sides. Now, negative 2 is multiplying times my absolute value, so I need to divide by negative 2. Remember to flip the inequality sign when you're multiplying by a negative. Now, I have an absolute value is equal to a negative. So we say, hey, we're done. There's no solution, but that's wrong. It says greater than or equal to negative 7. So let's think about it. No matter what I get, this absolute value will always be greater than negative 7. No matter what number I put in. I could put in negative 100 because an absolute value is always going to come out as a positive number, which means that it's always going to be bigger or greater than a negative number. That means it doesn't matter what goes in, it will always come out greater than the negative. This means my answer is all real numbers, which can be abbreviated the Gothic R. And if you had to graph this, you would draw a line for all the numbers to the right and all the numbers to the left. Okay, one last problem. Step number 1, isolate the absolute value. It's being added by 12 and multiplied by negative 3. We're doing PEMDAS backwards. Subtract 12 from both sides. Negative 15 and negative 12 is negative 27. Next, the opposite of multiplying by negative 3 is to divide by negative 3. Remember, dividing by a negative, we're going to flip the inequality. Negative divided by negative, positive 27 divided by 3, 9. Our next step is to break it into two separate equations. Remember, when we use the negative side, we have to flip our inequality. Then we just solve like normal. The opposite of adding 5 is subtracting 5 from both sides. 2x greater than 4. Divide both sides by 2. X is greater than 2. The opposite of adding 5 is subtracting 5 from both sides. 2x is less than negative 14. Divide both sides by 2. 2's cancel to give you x is less than negative 7. If we're to graph this, we have x is less than negative 7, an open circle because it's less than, and it's pointing to the left, so I point my arrow to the left. This says x is greater than. Again, it's an open circle at 2. It's pointing to the right, so I point my arrow to the right. Because these are pointing in opposite directions, I know that my answer is an or. So we say x is greater than 2 or x is less than negative 7. If I was to write it in the other notation, we notice that I'm going from negative infinity. So negative infinity, since you can't hold on to it, use a parenthesis, and then I go all the way to negative 7. Since it's an open circle, I use a parenthesis, union. Again, open circle, I use a parenthesis, 2, and it's going forever to the right, so I use positive infinity, close.